I'm going to apologize in advance because this talk was kind of slapped together at the last minute, not rehearsed and not, so you get what you get. I'm going to be talking about Git on Plan 9, obviously, as you can see from the slides, and kind of splitting into a few things. There'll be a bit of a refresher on Git, what it is and how it works. And then I'll talk a little bit about how it's implemented and how it fits better into Plan 9, the way I did it, rather than the way that Torvalds did it. It turns out that Torvalds Git's priorities was not fitting into Plan 9, which I'm very confused by, but to each of their own. Okay, so most people here, I'm sure, are aware of Git and have used it, but it's always good to refresh. It's always good to make sure everyone's on the same page, and sometimes the clear ideas that are in Git's internals are obscured a little bit by its UI, so cleaning up some misconceptions and some ideas about what Git actually is probably in order. So, first off, the very basics. What is Git? It's distributed version control. So, what does that mean? Version control, obviously, it tracks your code, versions it, allows you to go back in history, allows you to collaborate. Snapshot-based, so I'll talk a little bit about why it's snapshot-based rather than diff-based, and it's offline first, which, again, that's one of the things that makes Git interesting compared to the traditional old-style stuff or the Plan 9 alternatives that we could use. So, Subversion, CVS, and so on require a central server. So does Venti, so does Fossil. But Git, basically, you don't need to be on the same network or on the same computer as the people that you're working with, and you can kind of share the changes around, which is kind of useful for the new distributed development world that we live in. Okay, so version control. I'll just kind of refresh. Basically, you track changes to the code. You sync them, you manage branching and merging. Snapshot-based. So Git is basically built around the idea of taking snapshots of the code rather than trying to track changes over time. So every commit is basically an entire snapshot in time of your tree. It's built on it's a Merkle tree, and then the diffs are actually generated from the snapshot. When you do git diff or try to diff between changes, it just walks down the tree and does the diff on demand rather than storing the diff. And basically commit is, it creates a new snapshot. Merging takes snapshots, applies a whole bunch of transformations and creates a new snapshot. You can think of the snapshots as almost like just taking a snapshot of the current, well, instead of the data, it would be a hash, but the RC to actually generate a hash was a pain in the ass, so I just said, imagine you could just take a snapshot of, you just make a directory and copy the contents of the repository to the snapshot. And you kind of have this in history. You get something like this in Venti Fossil systems where you get your dumps nightly, and you can take the dumps manually if you want. But it's kind of building this kind of thing. Local first. So Git is, as I said, a distributed system. It's local because it's distributed. You have to deal with networks not being there. So everything is local first. All changes are made to a local repository, and all repositories are equal peers. So GitHub is not necessary for a development workflow. For example, you can just, if I'm on the same network as another machine, or I can reach them, and I have the auth credentials to, for example, SSH into it, or someone set up a server either way on the machine. I can pull directly from, your machine or your machine, and there's no central server needed. That also means that syncing is explicit. You push to a repo, you pull from a repo. So basically, it's peer-to-peer. Just in case I give it another talk, I'll just update the slide. Okay, so what is a Git repo? How is it structured? And I'll kind of give a quick overview of the internals of Git now. Basically, the Git repo is a Merkle tree. of snapshots. So you get three different kinds of objects in the repository. Well, actually four, but I ignore one in Git9. There's blobs, which is, there's blobs, there's trees, and there's commits. Blobs and trees commits, oh my. Blobs, trees commits, oh my. And then there's some metadata, so you can actually find find the right tree, and pull the data around from there. So blobs are typically file contents and just contents. There's no metadata attached. There's no file info attached. It's just you take the contents of the blob, of the file, or whatever you're tossing into it, and you put a header on it, compress it, take the hash of it. So if you have a Git repository, so now the question is, do I have, no. I should have prepared a repository here. Okay. So you can see that there are objects in the Git repository. So .git/object/hash. These objects are generated by basically slapping a header onto it with the compressed contents of the file, and that is basically what you get to in the object store. Then there's trees, which is basically the contents of a directory. So you get the file name, the permissions, and the hash of the blob that refers to a file. This is where, when you go into a Git repository and you try to do, you're listing the contents of the repository, this is where you figure out what the file name is. And you basically get that by taking a header with the type, compressing that with, and basically compressing the generated tree of the directory listing. So there you have the blob. There you have the object in Git. And then the last thing is the commits. Commits point to the root of a tree, and they contain all the metadata about the snapshot. So they point to the root of the tree, they have the commit message, the author, and they chain backwards to the previous commit so you can generate the history. So you get a linked list of history. There can be multiple previous commits. So for example, if you have a merge commit, it's just a commit, just a snapshot, but you point to two parent tree or parent commits instead of one, or three parent commits, or 75 parent commits. It doesn't actually care. And file metadata does not live there. So yeah, and you get this by basically just generating the commit from the author, date, parent commits in the tree. There's actually one last thing that's kind of nice about Git. It actually separates the author and the committer. So, for example, and you'll see this a lot in the 9.3 repo, someone will mail a patch as a contributor, and we'll grab the patch from the mailing list and say, me or Moody or Synap will commit it. So the author information is preserved, but we also know who actually did the commit. It's a nice tool for actually sharing and collaborating. Okay, so, and then there's the last thing, which I ignore in Git 9, but tags. Tags are basically a label for a commit. They're very similar to commits, but they're pointed at a commit, not a tree. As you can see, I'm very good at proofreading and checking my slides. So anyway, they're pointed at a commit, not a tree. And they don't move. So in Git 9, I mostly ignore them. There's a little bit where if I get tags when I'm cloning a repo, I'll create basically a branch that points at the commit and unwrap it. So you get, so you lose the tag, the metadata in the tag if you get that, but everything still works well enough. You can still check out a tag, you can still branch it. It's just, I didn't feel the need for tags, and I was lazy. Nobody has complained yet, so I think I made the right call. Yes.
Does that interact with the code whose code releases,
so when you
there seem to be patterns.
Yeah, I don't think that it matters the way we're using it, because tags are kind of half transparent. If you basically treat them like a branch, and so I'm not entirely sure. There are some ways that Go could tell the difference, and it could break things, but I haven't.
Well, I just meant if you publish something, whatever you do with tags, does it realize that that is not
That's a good question. I'm not sure. We can experiment after.
Yeah.
I think adding tag support wouldn't be hard.
But you might just need enough to get that going. So.
Yeah. It's really not hard to add tags. It's just that literally nobody has asked for it, so I haven't implemented it. I think it would probably be an hour of work to do. An hour of work and about 150 lines of code, mostly around formatting the tag and. Okay. And then there's one thing I haven't talked about, which is pack files. So if you saw me trying to figure out what I was doing and went, oh, I don't actually have the, I should have set up a repo. Where was this? Yeah, so when I listed the objects and there was only a directory called pack. What was happening there is Git also, because having all of these little files scattered all over the disk is slightly inefficient, Git also has something called pack files, where they basically take all of the blob or all the objects in the repo and convert them into a single file. So there's a little bit of an algorithm, but basically what you do is you take all the objects, cap them into one file, sort them by some certain criteria, and deduplicate the chunks, because most of the time you're editing files, you're committing something that's almost the same but not exactly, so why not share the shared parts and only keep the deltas? So while Git doesn't do diff-based, while its model isn't diff-based, the storage is deltafied. And in Git 9, what I do is I use content-based dedupe. Torvalds Git actually uses xdiff, so different algorithms. Mine's faster. Though I don't parallelize, so Torvalds Git actually deltafies faster in practice, but we've got better algorithms, damn it. And the other thing with this is that because you've put everything in a file, when you want to do a git pull or a git push, you only send a pack file. So you pack it up into one thing, and then you do a single transfer, and you don't have to worry about unpacking and tarring up a directory of objects. So basically a pack file doesn't actually change these are three types of thing that you have in your Git repo conceptually, but it's just an efficient way of encoding that. Okay, so that's a Git repo. And then there's the last thing, which is the metadata. And the metadata is roughly what you get for finding the stuff in the repo. Because otherwise you just have hashes. Everything is a hash up to now. Everything is, I don't want to say, oh yeah, do you, what changes do you have on branch successor of 3BEA 363? Yeah. So you want to give things names. So there are a few things that you want to give names to. There's .githhead, which is the current branch. It's a file that just contains the name of the branch, ref heads master. Or you could change it to ref heads, I don't know, front. If you created the Git repo on 9front, that's our default branch name. Then you have the actual contents of the branch. So and that's the commit hash of the commit. So you can actually go into the repo and change branches by doing, I don't know, echo oops. I don't know, let's go for that. Oops. Well, I cannot type. What did I do here? You get the idea. I also don't want to mess with my repo. So, but you can just, the branches are literally just files that point to a commit. And then within the, when you commit to the repo, it creates a new commit object and updates the branch file to point to it. A tag is, there are two types of tags. There's the tags with metadata and the thin tags. The thin tags are basically .gitrefs tags, whatever. Or they're an object in the branch. And then the last thing is there's the .gitconfig, which just configures things like where you pull from. Okay, so that's really all the metadata that you need. There's some other stuff that Torvalds Git puts in there. For example, because Microsoft decided they were going to use Git for their Windows repo, and Windows is a little bit, they've got a few years of code that's accumulated, and then, so it turns out that there's some performance hacks you need to do to, yeah, the rest of the world doesn't. That's a very short summary. So the reason that I did Git 9 wasn't because I wanted to host 9front on Git. It's because I had repos that I wanted to work on that were going to run on Unix, but also on Plan 9, and I got tired of trying to manually sync the code, trying to keep an HG mirror and a Git mirror, trying to convince people to use HG, trying to at some point I went, fuck it. This isn't worth the time. I'm just gonna Git one. We need Git. So I basically went, okay, fine. How hard could it be? It's actually, it took a while to get it to usable, but not that much. So the way I tend to work, people that know me will notice that I kind of take a stab at a project, back off, give up on it for a little while, and then take another stab and go, wait, why did I find it that hard? So what happened with Git was from the time that I started thinking about writing it and decided, I'd like to build it, to the time it was usable, took about, usable enough to self-host was about a year and a bit. The amount of time it took from the second attempt and the first line of code that was written in the current version to usable enough to self-host was about a month and a half. So it turns out it's not that hard to get something that works. And then it took another year to polish and find the bugs and get things to the point where I was confident enough to actually use it to host the 9front repo. But it actually turns out that getting the basics wasn't that crazy. So and Merlin was the project that that really got me going. Like, fuck, I want to put it to Plan 9. I don't want to grab it back and to copy this stuff back and forth. So yeah, I basically just implemented Git and made my workflow painless. Another good example, though this came way later, is NetSurf. So NetSurf is, for the people that aren't aware, it's a web browser. It's somewhat more capable than Mothra, but significantly less capable than, say, Chrome. It's a friendly fork. Upstream doesn't want muck files. They don't have Plan9 to test on. And really, I don't think anyone here or in the Plan9 community really felt the need to push it hard. The code for portability is well separated. It's cleanly clean. There's a clean abstraction layer. So keeping things, and NetSurf doesn't change that quickly. So keeping a friendly fork where we maintain the Plan9 parts and they maintain the rest of the browser turns out to be relatively, it's a good model. So what we do is we basically, when there are changes that make sense to go upstream, we collaborate. When upstream makes changes, we pull them in and do a merge, and then we add our own stuff on top of it. And the way that Git works, it makes it really easy to kind of, we're going our own direction, they're going theirs, and we keep in sync. So I think this is a good model for porting code in general, where we basically end up with, hey, look, Plan9 is a weird system. We've made changes to make things fit. Your code, we don't want to burden you with that. We want things to be easy for you, and so we'll maintain the Plan9 part, you maintain the rest of it. And having Git work this way is actually, having Git makes this collaboration much easier than, say, the BSD ports style system where you've got a repo of code to clone something and then apply a bunch of patches. And then you have to do a bunch of work to manually update those patches periodically. I think this is I think the BSD port system has its place, and it makes a lot of sense historically before Git 1. And not everyone was, people used to distribute code in tarballs. They still do, but now it's much slower effort to just clone a Git repo and apply a bunch of patches. So collaboration is nice. And then finally, why are we self-hosting on Git? Because, honestly, just because, this slide is actually slightly misplaced. I'll get back to this. And then finally, Venti. Venti has the right idea. Oh, sorry. This slide is slightly misplaced because I wanted to talk about why are we using Git. So, we use Git in 9front. Again, when I talked about external reasons to use Git, so Git 1 gets used everywhere outside of Plan9. But we're Plan9, we do things our own way. Why are we using Git for Plan9? Well, and there are several options out there. For example, the labs used Venti and Patch. 9front was on Mercurial for a while. Why Git? Why Git? Well, so Venti, honestly, for a project where we're working distributed, everyone's doing their own thing and eventually kind of shipping things back. Or maybe not. Gnome's got his own ants port. And then I've got my own patches to my system. I'm pretty sure a whole bunch of other people have got the Rio theming patches. So Venti really doesn't have the tools for us diverging and keeping our stuff in sync. It doesn't have the ability to kind of ship changes between people easily, or ship parts of the tree as changes. So you end up needing to kind of build a bunch of tooling around it. We could build it, and that's not impossible, but then what? Set patch, set apply. How about offline work? How about cherry picking? How about I run my own system, and how do I sync it with yours? Well, so Mercurial, again, it's okay. It's dead. The big problem with Mercurial is, well, it's dead. There are places that use it. Facebook has some internal tooling around it, but I think they're trying to move to sapling. The other big problem with it, it's full of snakes. And this isn't in theory, and by that I mean it's written in Python. And that means we need to port Python. We had a port of Python. We were using it. It was Python 2.5. It was a Python 2.5 with a ton of patches to integrate with, say, Factotum and the 9front and libsec and a bunch of the other Plan9 bits that you just expect if you're running on the system, and keeping that up to date with upstream meant a ton of porting work, and so nobody ever did it. So the release that moved to 9front had a nice crashed plane with a little Python logo, snakes on the plane. The snakes are gone. And that release deleted upwards of 1 million lines of code when we got rid of Python. So there's and added about slightly under 10,000 for Git. So, yeah. Exactly. I've run ahead of myself and talked about this slide already. So, again, so why Git? Because it's useful elsewhere. It's not just useful on Plan9. It's small and maintainable. It's distributed offline, and you can self-host it. So, sorry, it is self-hosted. We can self-host Plan9 on it. So, for example, git.9front.org. Git.9front.org runs on Plan9. It's running on it's using git serve, it's using listen, it's using all of the tools that we actually want maintained. And if you're not using the tools, why are you maintaining them? What's the point? If you're not using them to build things, you're not going to run into the bugs. Things are going to bit rot. Things are not going to keep working. So it's important to self-host. It's important to if you're going to maintain the system, it's important to use it. This is just my view, but yeah. Shithub.us, it's another example, self-hosted Git repo. And it's also kind of a community hub. So if you want to grab Plan9 software, you know where to get it. Not everyone uses it, but a bunch of people do. It means that to be able to get onto it and to push to it, you need to be using Plan9, or at least you need to have set up a whole bunch of Plan9-ish infrastructure to be able to auth using DP9IK and to push to it. So being able to, so basically having this kind of tongue-in-cheek, slightly, unprofessional but fun little. Okay, fine. Oops. Alternative name, by the way. Slightly tongue-in-cheek, tongue-in-cheek, fun thing. People kind of go, that makes me laugh. You know what? I'll join on. It's not for everyone. Doesn't have to be. I'd be happy to see someone else host something else. But having things like this, actually, I think that there's also tcp80.org, which is, if you want to be able to link to it professionally. And you can also use hjgit.org, I think, to get to 9fen, to this hosting. So there are different names for it. Some of them you might or might not want to put on a resume. Shithub's on my resume. Nobody's batted an eye at it, but there are other, if you're a little bit less daring, there are other ways to put it up. Okay, so, but having this kind of, hey, let's have hosting that you actually need Plan9 to use, helps grow the community, helps get people kind of interested, and helps people get kind of like, hey, I want to try this out. This Plan9 thing is weird. You know what? I should give it a try. So, for example, we have, who was it? One of the core boot related forks. I don't remember which one. I'll remember soon, but they basically went, hey, I don't really use Plan 9, but I'd like an account. I'll set up Plan 9 to use it. I don't know if they actually did. I don't think they ever went through with it, but they were interested enough to ask for it and tell me that they were going to set up a Plan 9 system. So, yeah.
We actually used to load Plan 9 right out of Corbett.
Maybe. But no, I think they just said, hey, we want to have things on a few different Git forges, and this one seems fun. Okay, so Git, how is it structured? So this is the part of the talk where I actually talk about Git on Plan 9, as opposed to just Git and why Git around Plan 9. How much time do I have, by the way? Whatever, we'll find out. Okay, so the structure of Git on Plan 9 is basically, it's actually kind of similar from the Torvalds Git. It's got a core of C programs, which give you access to the structure of the repo and provide ways to manipulate it, and a whole bunch of shell script wrappers. Again, not that different from Torvalds Git, but we have GitFS, which means we can do it better. Oops. This is where I apparently forgot to save the slides. Shit. Okay. I promised people this would be a bit of a disaster, so yeah. Okay. So there's so the core of it's GitFS, but okay. I'll start with the more peripheral bits because we can kind of work through that. So one of the core parts of Git is git save. So what git save does is it basically creates a snapshot of the repo with a commit message and the author and the all the other metadata you need in the commit. So, for example, you give it the name, email address, message, date, and a list of files. And this creates a new repo and a new commit in the repo. So git save is fine, but you wouldn't use it by hand. It's actually wrapped up by git commit. And git commit is a fairly large script that does all of this stuff to figure out, first off, who is the author, who is the committer, because you don't want to type that in every time you're creating a new commit. It finds the current branch because you don't want to commit every branch. You don't want to tell it which branch you're committing to. That's just a pain in the ass. It figures out which commit you're on and what the parents are. So if you're creating a merge commit, git merge will save a record of what the parents are, and then you commit to save that. It'll allow you to edit the commit message, create the commit, and then update the branch to point at the newly saved commit. Because git save just creates the commit. It doesn't actually update a damn thing. So you end up with an orphaned commit. So git save is a tool that you use to implement git commit, and that's really the reason it's there. The other parts of it are easier in shell, so you have a wrapper script. Nothing mind-blowing there. You have a core tool and a wrapper. Similar with git send. Git send pushes the data to the repo. It doesn't know which one, but you've got and it doesn't deal with it. It just does exactly what you tell it to do. And then get is kind of the opposite side. So it pulls the data. It's similar to git fetch, but not the same, and it's different enough that there was some confusion. At one point in history, it was called git fetch, and then I went, okay, people are trying to run git fetch and expect it to do what Torvalds Git does, so now it's called git get. Okay, git get just pulls the data from the repo, and then you have git pull that does all the wrapping and figures out what branches you actually want to pull, pulls them down, And then the interesting one, GitFS. So GitFS lets you explore the repo as a file system. So you have your head, and that head, for example, was written by Synapse, of course, which, oh, yes, there are a few recent commits that fixed some interesting bugs in the kernel, obviously. And then you can, oops. Yeah. Remember where you are. So you can basically walk through the files from the gitfs. And you can also is that it? No. What was in there? Yeah. So that's a commit hash. And really the head is just a, I keep on doing that. Is just an alias for the current commit hash. So you can do everything by hash within the file system. Having this, even though it's read-only, it is really useful for being able to write scripts. So all of the tools like, git commit, git revert, git merge, etc., are all, super simple little wrappers. So, for example, git diff, this is the core of it. There's a little bit more setup, but all it does is CDs to mount scratch, which has been set up as just a place where you can bind things. It binds the two places to the right place and then does diff-u. And hey, in Torvalds Git, there is thousands of lines of code wrapping around how do we actually diff these trees. Here, yeah, we've got diff, just use it. Tool-based approaches. This is kind of the bread and butter of Unix. And file systems really do that. Really do kind of make this sort of thing easy. Git revert. Again, I've only copied and pasted the core, but you get the clean name, etc. You basically figure out what files you're trying to revert, figure out where they live in the repo, figure out where they are relative to your current working directory. This is a kind of a messy thing. And then, sorry, I did miss one more core piece, git lock. Git lock is basically something that figures out, well, it's semi-core. You could do it as a shell script, but what it does is it looks at the files in your current working directory, the files that are checked in, and goes, these ones are dirty, these ones are clean, and makes it easy to say, hey, only walk through the files that are, only print the path, and only list the files that are removed or modified, so filter to removed and modified, on branch query with these files. And then just for every one of the files that is removed or modified, create the directory, copy the file from the tree, and then touch it so that Muck or whatever else will realize, hey, this file's been changed since the last time you built. The first version of Revert, by the way, did not have that. And I spent so much time being frustrated and wondering, why the hell am I getting out of date builds? Why the hell is it taking these old files? Yeah, and then git add basically just says, hey, if this file has been modified, mark it as dirty in the tree. And that's a little bit of a, that's a little bit of a hack around. So we've got an index, and this index contains a cache of the state of the file, the QID, so, and then the permissions. So if any of that's changed, or if it's no QID, then we look it up and we don't need to walk down to the file, open it, check if the contents are the same as what's in the Git tree, and that tends to be slow. So this is kind of it would be lovely if we could just do things directly from the tree, but this is a bit of a performance hack. You can just, and then the other thing is that if I do a git add, it adds it to the end of the file. So like, let's see. For example, and it should say, oh, well, it should say that I added this file. I probably screwed up something. Oh, am I in the right directory? Yeah, I'll figure that out later. It's not important. But you can just add to the index. It's just a flat file. It does get sorted when you do the git walk. But that's just, again, for efficiency. Okay, so how do you, what's the command? So this is just kind of a quick summary of what the differences are between plan9 git versus 9front git. So git init, well, it's git init. A lot of the stuff is you just put in a slash and you get something very similar. Git config, you edit the git config in your editor. There is no tool for that. Git pull gets turned to git pull, git fetch gets turned to git pull -f. So for fetch, git merge is just git merge. Git diff -- cache is git diff. There is no direct equivalent to git diff because git diff does something that's entirely asinine. And that's because Git has this thing called the staging area, and the staging area is entirely asinine. There are people that have different opinions. They're wrong. The very short summary, there are things that are nice to do with Git with the staging area, like committing just a single change from a large file. Oh fuck, I have a typo. The rest of it, this isn't ready to commit yet, but I should really push that one little typo. So git add -p or git is something that people will sometimes use, or git commit -p. We don't have this done yet because nobody's really put in the work and I'm lazy. But we can do better with something like a shadow fs. So you basically what I would do if I was building this for plan 9 would be have shadow fs as a general purpose thing, shadow the clean repo, and then just use, idiff to pull in the hunks from the dirty repo that I want to commit. Shadow that, and then commit that shadowed version. And now you've got something that gives you the benefits of the staging area without needing to put in the stupidity. So that's that. There's a lot more, which again, I screwed this up, so I apologize again. So, what does the workflow look like? If I'm hacking on things myself, well, I'll do exactly what I did here. I'll bind just plan9 front to /. I forgot to mention. So Git in plan9, in 9front at least, isn't just used as our version control system. It's also the way we distribute updates. So sysupdate, sysupdate is just a little shell script that figures out the branch, makes sure that you're in the right place, and then just does a git pull. Nothing crazy here. So, oops. Then you commit the files that you're changing and push. If you're not confident enough to just push it, and you want some code review, well, we've also got some useful little scripts. So you can bind, you can hack, and then what you do is you do git diff and then mail it to the 9front list, or git export it. Either way, both work. And then on the other end, when I want to import it, what I'll do is I'll just bind the repo into the namespace, run upasfs, and then git import. Git import knows about the structure of upasfs, so I just give it the mail ID, and it'll pull in the repo, create the commit. And you have a really nice workflow for code review, for mailing patches, for shipping stuff around. You can also do something along the lines of either way it'll work. And this is how if someone's not wants some review, or if someone wants to send a patch on the mailing list or send some changes to 9front and they don't have commit access, this is how it's done. It's easy, it's simple, it's fast. There's no futzing around with there's very little futzing around with stuff. Yes.
Yes. So specifically, one of the lessons that does mean code review is this one question. What we really want to do for receiving things is want to try them out.
Yeah.
Rather than just look at it and say, "Oh, it looks good to me." Well, the computer disagrees.
Mm-hmm. Sorry.
This is a nice way of separating them.
Yeah. If you want to just test it without committing. And then the other thing here is that Git, the Plan 9 Git actually has a few small tweaks to the way that patches get applied that make it easier for you to run with local changes, or to just import patches that have already been applied. So what happens is, in Torvalds Git, what will happen is if you've got local changes to a file, it'll complain and say, I refuse to change this. In Plan 9 Git, what we'll do is we'll actually do a merge of the files. So you'll get, so if you try to apply a patch to or if you try to pull and there's already a patch that makes the same changes to a file that you've got patched locally, well, it's just fine. We'll just merge it in. Everything works. And this is, again, because the way we use the system, we tend to have a bunch of local patches that, hey, I want to have Sigrun's, well, I don't want to have it, but someone wants to have Sigrun's Rio theming. Someone wants to have, my tweaks to how, actually, what tweaks have I done? I have all of my local changes that are probably broken, or the changes to integrate GEFS into stuff that aren't ready to push yet. And when that does get pushed, the systems that have it locally will just work. Okay, so yeah, I wanted to talk about how I host it. I'll talk a little bit about that. And then, the last thing with hosting. So this is, let me just log into one more system. By the way, is this font size good for everyone? I should have asked long ago, but fine. Okay. Oh, sorry. Sorry, RC. Oh, fuck. Okay, so with Git, basically, there is so there's the unencrypted Git protocol, where basically this is the way I set up a Git server for unencrypted Git. Hash pound bin RC, and then I exec git serve -r the path to the Git repository. And that's basically the base where we start searching. So that's the way that hosting works on GitHub. There is an extension that I would like to get to upstream Git. I've also got the OpenBSD Game of Trees implementation of Git interested in this, which is in 9149. The same thing, except we wrap it with TLS serve and get encrypted Git protocol. So this is completely unencrypted Git. Encrypted Git lives on port 9149 for us, and we can actually serve Git over TLS without auth, so anonymous. And then finally, I think it's this one. Oops. this mouse is not the best either. So where we basically do TLS serve -A, and that tells us to use Plan9 authentication to allow Git to or to set up an encrypted tunnel. So this is the config for getting DP9IK, and the -W allows you to write. So if you authenticate with DP9IK, you can push to the repos in user-git. And everything there happens with the standard Plan9 permission. So if you auth as Ori, you can push to repos that have the file permissions that Ori allows you to write to. And this is everything I need to do for git serve. Small little sneak preview here. The Acme certs are used for the TLS stuff. So we have a little honest Acmed, which lets us basically pull the Acme certs for serving TLS. So I think setting up Git, as long as you're not trying to do the web interface stuff, I think Plan9 is the easiest system to host Git from out there. If you do want to serve, the web interface, you just set up. The way shithub works is there is a TCP/80 script which runs the execfs with some Git rules to cat the repo using a shell script, and everything there just kind of is an RC script. So, and this is how our web UI works. Oops. So you get things like, I'll just do the view raw because it's tiny. Oops. Or actually, let's see. Oh, actually, tar. Oops, tar. So tar basically sets up the repo namespace, which is just a little bit of protective sandboxing. So basically, we bind it so that as little of the repo is available as possible outside of this namespace. And then we just kind of either we resolve the reference or not, and then we just tar the repo and gzip, pipe to gzip, and that's how you can grab a tarball from the website. You get similar stuff for like you get show, which has a bunch of HTML, and then we cat the commit message, the date, and the author. All of this is just stuff that we grab from the file system tree. And hey, this is how we serve Git. This is our Git web. And I want to take the time to thank Phil9 for doing this work so that I didn't have to. This is mostly not my code, the web UI. Okay, so I think that's basically it. The talk title up here says I should be asking for questions. So, questions.
Two questions. So one, checking out kind of hashes. There is no git checkout command. Yeah, I checked. So
create a new branch.
Yes.
Give it a name.
But it took me like a good hour to figure out how to properly check it out. So maybe just, I don't know, have a command, or maybe just a note in one page that this is how you check out stuff.
Yeah, okay.
And the second one, I guess, would you consider backporting this to legacy? Legacy?
No, but I'm happy to take patches if someone else does.
All right. Okay. Thank you.
So for hosting Ninefront, how do you deal with Git's kind of anemic metadata on files? Like file permissions, the appended locking bits on files. How do you deal with the fact that the Plan9 tree has those Git?
It doesn't seem to have that many of them. I don't think we've really run into that as a problem. There have been places where we got permissions wrong, but the other thing is that if we mostly store the source code, and then if there's things like the silent removal of empty directories. We'll have a script like root step that'll put them back. It kind of sucks. And actually, the empty directories, I've got a plan to. It turns out that the repo format allows them. It's just the Git UI doesn't. And I see why. It's a little bit of a pain to say, I want to add this directory, and wait, do you want to add the directory, or do you want to add the files in? And most of the time, 90% of the time, you want to add the files. So having that kind of distinction with command line flag or something is a bit of a pain. Actually, I just had a thought. You don't necessarily need a command line tool to deal with it all the time. You could just, I could just add a flag to Git, or I could have Git save do the directories, and maybe you just fall back to the raw thing when you need to create those directories. So Git commit knows. Yes.
So important to add on additional metadata. A lot of that's handled by AKFS copies. You have a bigger file as opposed to the metadata solution. You need ISOs or you install the one that does that actually says everything in system log is by default depend only, and that's how it works.
Yeah. I'll just repeat the answer because I don't remember if I don't know if that picked up very well. It was kind of quiet from the front here. So basically, when we create the ISOs, the makefs tools will also just change the permissions to what they should be in the tree.
Is there any appetite for having Git 9 delivered on Unix? Using an interface or
Again,
in the slashes?
I'm not going to do the work. The code's there. The code's actually, so Git trees, the OpenBSD Git thing, is, well, their interface is very, very different, but they have stolen a bunch of my code. So it's a friendly steal. So I encourage them. But if I look through the, for example, I don't know, the pack file parsing or the protocol code, oh yeah, they've changed the names completely to match their style and their taste, but the structure is kind of similar. Yeah, I'm familiar with this. Also, goddammit, grow your vectors exponentially. So, anyway, the code can be ported. The file system approach, maybe you could do it with Fuse, or maybe you could do it with NFS or 9P. Good luck.
I'll take NFS.
Yeah, feel free.
Yeah, Fuse.
Fuse might. Let me know how it goes.
Yeah.
Again, it's one of those things where, yeah, do what you want. I'm not doing it. Anyone else?
Just, I'm curious. I couldn't quite figure out. Would this make the work trees stuff they did easier recently in Git? I was trying to figure it out, and I can't figure it out.
I think so. I mean, it's basically going to be binding the repo into the work trees a few times, and then you just you bind the object store, and then you have separate metadata. I think that would be all you need.
But you can do commits. The work trees are writable. With that, you'd still have that, right?
Yeah.
That's great.
Because of the way that everything's a Merkle tree.
Yeah.
The only thing you have to worry, every object is just kind of completely separate. There's no worries about things typing on each other's toes other than metadata. So the branch names, the head object, the head file, and the git config. And even the git config, you can bind it.
Yeah.
You're not changing that very often. So it feels like you can just, a work tree would be a tiny little script.
It's seen that way.
Yeah. And I'm thinking, if I was implementing it with Git 9, I'd put the work tree in the git config, and then just have, so there's a little bit of a utility script that every git commit sys common.rc, and in common.rc we have a little function called getup, which figures out the root and sets the file system and so on.
Oh, okay.
We could probably have it do something along the lines of if
Yeah.
something like that.
Yeah. Just another, because the
Yeah,
amount of junk they added for work trees looked pretty horrendous. And
yeah,
this is like showing that you get the same behavior at the cost of very little work, which is kind of neat.
yeah. I think I've implemented it. Uh,
But yeah,
I think that's the implementation.
yeah, very nice. Yeah,
And you just the work.repo, you basically have something in your commit that in your git config that looks like.
yeah. Jeez. Yeah,
I think that would work.
yeah. Very, very cool.
Is that also not an example of how laziness is very helpful?
Yeah.
Is it, who wants to do thousands and thousands of lines of code? Oh,
You know
not
what?
just bit,
I
I
think-
to structure the thing so that a few lines of shell will do it.
I think the laziness is in writing thousands of lines of code, and the art is doing this. Honestly, people just churn out the code.
I mean,
It's hard. It's easier than thinking about it.
and I'm sure that someone was paying for it, so that you have to show that you're doing hard work.
Probably true. That's true.
Yeah, I couldn't justify a month of salary for that. Yeah.
You mentioned in one of your scripts that copying one file from one directory to another was not sufficient to get Mug to know that it needs to be rebuilt.
Oh, we preserve the timestamps and Mark looks at the timestamps. Yeah.
In copy.
Yeah. Or at least there was a flag that was used to preserve permissions, which also preserves timestamps. And that was the dumb mistake. Okay, I think I'm not seeing anyone else with hands up, so yes.
You mentioned Venti in the beginning. Do you think there'd be any benefit to just putting it directly on top of Venti? Just using it as the object store?
I think that would be,
Compatible hashes.
yeah. You could do something that worked very much like Git, basically take all of the scripts and the tooling and make it work on Venti, on a Venti-based thing where you have the Venti score. And I think that would work well. No, do you know if there's a limit on the blob size in Venti?
51K.
If you want
Yeah,
to,
you can, it builds up the tree, so if your CVAC just build up these almost smaller blocks of time.
yeah. I guess you could probably point it. You can use a BFS and point it at the Venti root score, or something like that, and that would give you the tree that you're trying to mess with. So yeah, you could definitely build something like this on top of Venti. As I said, one of the big motivations, especially initially, was I want to clone a Git repo, and Venti doesn't help me. On the other hand, if you wanted to do something native Plan 9 and you were ignoring the outside world, I think Venti would be a good tool to build on top.